Hello, greetings. I want us to give you a sneak preview of the reverb delay unit that I'm building. I'm going to walk you through the different section of the unit so you could get a little sneak preview as to what goes on when we're building these units. The first section of the unit here is what we call the differential amplifier section of the unit. And this is the typical what you call XLR input line amplifier. This section of the unit is a spring drive section. This is a special section that I designed so that the spring get a constant drive. And let me demonstrate what I'm talking about. Right now we have the input voltage set at 100 millivolts and it's producing this output. Look what happens when I carries it to 200 millivolts. It produces the same output. Look what happens when I carry it back down to 100 millivolts. You have a slight reduction and then it brings it back up. The other section of the unit is what we call the recovery section, and what this section does, it recovers the reverb sound from the tanks. We're going to be having two reverb tank 1 and tank 2. The other section of the unit is the delay section of the unit, where we're using a delay IC, the PT2399 chip. The other section of the unit here is the line out section of the unit, and this is what we call a line driver. This is a line driver chip that we use to drive the XLR out. The other section is the high pass, low pass, band pass, notch filter section that we put in the unit. And then again, here is our what we call RMS detector section, and what this section does, it converts a AC voltage into a DC, and this is our what you call, this is like a typical power supply that you'd find just about in anything. The other section of the printed circuit board unit is this is the back layout of it. The back layout where we're going to be having the knobs. So we're going to have one XLR input and two XLR output. This is the section that we have the power transformer, and this is the section where we have in the input module. So if you like, say if you overseas somewhere in the UK, you can switch from 110 like what we use here in the US to like a 240 volts like what's used in the UK. The other section is a front panel section where we're going to be having all the different knobs like freeze, reverb drive, the recovery, and we're going to be having the high pass, low pass section, and we're going to be having resonance, notch, band pass, high pass, low pass. The other section of the unit is the printed circuit board area, where this is the layout of all the parts on the board. And nobody sit down anymore with a soldering iron back in the old days and do printed circuit board work or build anything. Everything nowadays is done by robots. Robot is what put all these parts on board and wire and lay out everything. Right now the board is in the routing mode and it's routing the board, and if you pay close attention you can see where it writing the traces, and it's deciding the best place to put each wire on the board. After that is finished, then it will check the board for errors and make sure that everything is working properly, so that when I go to manufacture the board it will be error free. And it's a bunch of different procedures that we go through before the board actually hit the market, and this is one of the most critical area where we route in the board after we put all the parts on the board. We have to route the board, put all the parts in the right position. Example, the power supply part here, where we have a power supply input module, right? We have to construct the board where we don't put the power supply input module near any of the input terminals, right? So the objective is to keep the input modules and all the audio modules as far as possible from the power supply unit, because it give off all kind of noise that you don't really want in your circuit or in your reverb unit. So it's about finish wiring up the board now, and after that, well, then everything come back perfect. There's no errors. Can check the board for errors. Oh, it came up with one error. This one error here, it's saying that a net zero is too close. So I'm going to fix it by moving this trace over, and then if you notice, it got rid of the red there, and there's no more flags here. So that's indicating that the board is working correctly and everything is laid out properly. This is what the board looks like in a 3D view. This is a 3D view of the circuit board, and after it comes back from the manufacturer, then everything is going to be exactly just like this. Thank you for watching. Talk to you. Bye bye.